Hello, welcome to Zigmatech Learning Hub. I'll be your instructor for geography. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GCE, KCPE, IJMB, JUPEB, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. So, in today's lesson, we will consider the topic that says the shape and size of the Earth. In this lesson, we are going to look at the basic facts and figures of the Earth as a planet in terms of its shape and in terms of its size. And also, we are going to look at the evidence for the Earth being spherical in shape, as well as looking at the movement of the Earth since it's spherical in shape, such as rotation and revolution. So before we actually commence, let's just consider the Earth. Let's just look at the Earth. Now, if we look at the Earth over the years, we've had so much argument about how the Earth looks like. People will come up with the fact that the Earth is flat. Some persons will say that the Earth is round. Some persons will say that the Earth is maybe round or maybe flat. There's been a whole lot of arguments, surrounding how the Earth looks like for a very long period of time. Not until recently when, people discovered different reasons why the Earth is not flat but round. And as at today, it has been proven beyond doubt that the Earth is actually round and not a flat land. Now, let's look at the shape of the Earth. Now, in our present day, we've discovered that the Earth is not flat but round and spherical in shape. But the thing is this: the Earth is not actually a true spherical shape. The Earth actually has the surface of it, that is the poles of it, flat on the poles, and at the equator it's bulging in size. So we can as well compare the Earth shape to the shape of an orange, where if you look at the peeled orange we have here, you will discover that here is a bit flat, and at the equator, at the midpoint here, we have it bulging out. That's how the Earth looks like, and we actually call this type of shape a geoid shape, G-E-O-I-D-S or G-O-I-D, and it means the Earth's the Earth's shape. So the Earth shape is not a perfect spherical shape. So that's how the shape of the Earth is. So the Earth has a geoid shape. Now let's look at the size of the Earth. How big is the Earth? Now, the Earth in terms of size is the 5th largest planet we have in our solar system. The Earth is the 5th largest, and it has a total surface area of 510 million kilometers square. That's the total area. Then in terms of land and water, the Earth is actually 2/3 of the Earth is made up of water, while 1/3 of the Earth is actually made up of land. And that 1/3 of the Earth actually has a land area of 148 million kilometer square. That is 148 million kilometer square land area. Then for the area of the Earth covered with water, we have about 382 million kilometer square. That's to say that 2/3 of the Earth is basically what? Water. Or will I say 2/3 of the 510 million kilometers is made up of water. So let's look at the other facts about the Earth in terms of circumference at the equator and circumference at the pole, and also in terms of diameter at the equator and diameter at the pole. Now, if you look at the Earth, you will discover that the circumference, as you head towards the pole, becomes smaller, but the circumference at the equator is much more bigger. So at the equator, the circumference of the Earth is approximately 40,085 kilometers. That's the distance around the equatorial zone of the Earth. But if you go towards the pole, the polar circumference is about 39,955 kilometers, meaning that as you're moving from the equator to the pole, the circumference is approximately 39,955 kilometers. Then let's talk about the diameter of the Earth, how wide the Earth is in terms of diameter. Now, if you look at the Earth, at the equator, the diameter is the longest, which is about 12,762 kilometers, and that is actually the diameter of the Earth. But when you go towards the poles, the North Pole or the South Pole, the diameter of the Earth becomes smaller. So what we have is that the diameters at the poles are approximately 12,722 kilometers square. So that's the diameter for the Earth at the equator and the diameter for the Earth at the poles. So let's go over to the part where we have the scientists proving that the Earth is spherical in shape. Now, what are the reasons we have to back up the reason for saying the Earth is spherical in shape? Now, there are lots of reasons, and we're going to mention them. The first one is the circumnavigation of the Earth. We have the circular horizon of the Earth. We have the sunrise and the sunset. We have the ship visibility. We have the sphericity of planetary bodies. We have driving poles of equal length on the Earth. We have lunar eclipse, and we also have aerial photograph. So we're going to look at them one after the other. Now let's look at the circumnavigation of the Earth. Now, the circumnavigation of the Earth was an experiment firstly carried out by a Portuguese explorer or a sailor by name Ferdinand Magellan in the year 1519 to 1522. Now, for that period of time, Ferdinand Magellan and his crew, or his teammates, they actually got on board on a ship and went around the Earth in the space of that 3 years. And now the thing is this: if the Earth were to be a flat Earth, they would have possibly fallen off, from the Earth. So when they went round the Earth, they didn't fall off, and with that, they concluded that the Earth is not flat but spherical. So in a flat Earth, while you're going around, you can fall off from the Earth into what? Space. But Ferdinand and his crew never experienced such. So as a result of that, we can also say that that the Earth is round and not flat. Then the next evidence is the evidence of the circular horizon. Now, if you look at the cloud, the horizon of the cloud from a far distance, or let's say you view a ship, from a cliff coming. Now, when you look at the sky or the clouds, you discover that the way it is arranged or the way it is structured, it looks like a curved sphere, like from afar. So when you look at the extreme, of the cloud or the atmosphere, especially on a sea or on a highway, you watch the horizon of the atmosphere being curved towards the end, and it's as if the Earth, curve downward, just as we have on this picture right here. When you look at the clouds here, you see that it's as if it's ending somewhere here, and the cloud is curving towards this end. So with that, people began to say that the Earth is what? The Earth is round. The Earth is not curved. If the Earth is actually flat, as some other persons may say, you discover that this horizon we have here will not be curved. Instead, it will be like a flat canopy. So let's look at the next evidence we have. The next evidence is the evidence of sunrise and sunset. As the Earth is rotating from west to east, now you discover that in the morning, you see people in the east will experience sunrise. The sun will rise from the east and it will set in the west. That means people in the west will see the sunset later in the day. Now, if the Earth is flat, the thing is, everyone, be it people on the east or people on the west, will experience sunrise and sunset simultaneously. That's to say that people in the west and people in the east will see when the sun is coming up, and when the sun is going down, they will also see it. But we have an Earth where sunrise is only seen by people majorly in the east, while sunset is experienced by people in the west. So if we have such scenario, it definitely means that the Earth is round in shape, and people on this other side will see the light, while people on this other side will see the setting of such light. So we can say that based on these different time events of sunrise and sunset, the Earth is actually round and not flat. Now let's look at the next evidence of the Earth. The next evidence of the Earth is called ship visibility. Okay, now if you go to the seaport or the river port we have, now when you observe a ship coming from afar, now the first thing you see when a ship is coming from afar is the mast of the ship. You will see this mast of the ship from afar. Now as the ship progresses forward, you begin to see the other sides of what? Of the ship. Now if the Earth is flat, when a ship is coming from afar, you will see everything about the ship. In fact, you will see the ship the same size as it is from afar, and just as the ship will be when it's also close to you. But if a ship is coming from afar, from such a distance, the ship will actually look like a boat. But when it gets closer, it looks bigger. That's to say that the Earth is curved. Because if the Earth is not curved, such deception will not be noticed. You will just see a ship from afar, you know that that's a ship, and when it's close to you, you also know that that's what? A ship. But from afar, the ship looks smaller with just the mast, then a little part of the body, then the full part appears as we progress till we begin to see the entire ship close to close to us. So that's what happens when the Earth is when the Earth is round. So this is one evidence that the Earth is round and not flat. Then we look at other planetary bodies. Now, if we use what we call a telescope to view space, we see other objects in space in form of what? In form of a sphere. Now, if you use the telescope, you can see planets like Mars, planets like Mercury, Jupiter and Saturn with a telescope. And these planets, they are actually round in shape. Now, if these planets are round in shape, it definitely means that the Earth is also what? Is also round in shape. If the moon is round in shape, if the sun is round in shape, when viewed from a telescope, if Mercury, Venus, and Mars is round in shape, as well as the Jovian planets being round in shape, so we can as well conclude that the Earth is not an exemption. So the Earth is also a round object and not a flat object. So let's look at the next evidence we have. The next evidence of the Earth being round is when we drive poles of equal length to the Earth. Now, this is how this experiment is carried out. We make use of 3 poles of equal length, and we put them into the Earth's surface on an equal depth. So we dig the same depth of hole for the 3 poles at different distances, and we place them right into the Earth and bury them there. Now, when an observer, observes these 3 poles, you discover that the pole at the center will be slightly higher than what? Higher than the other poles at the other 2 ends. Now, the thing is this: if the Earth is flat and these 3 poles are actually, kept on the same level, we dig the same depth of hole for them, and we place them on the same height. But while observing the poles are unequal in height. If the Earth is actually flat, when we view this, we are meant to see these 3 poles on the same level. But since they are not on the same level from the eye of an observer, it definitely means that the Earth is what? The Earth is round and not what? Flat, because being flat is supposed to make us what? View these poles on the same level. But since the Earth is round, when we observe, we see what? We see the one in the middle slightly higher than what? Higher than the other. So with this experiment, we can also say that the Earth is what? The Earth is round and not what? And not flat. Now let's look at another evidence that we can use to say that the Earth is what? Round and not flat. We call it the taking of what? Aerial photograph. Now, when we take a picture of the Earth from a very high, altitude or height from the sea level, maybe we use a rocket or we use a drone, to take the picture of the Earth. Now, most times we end up seeing these images of the Earth as being what? As being round. Let's say, for instance, a rocket is being projected towards the sky, maybe possibly close to the exosphere, where we have the outer layer of the atmosphere. Now, when the picture of the Earth is taken from such a distance, you will discover that the Earth will look curvy and round in those images. And this is one evidence that we can use to say that the Earth is round and not flat. Because when we take these images and the Earth is not curvy, just like this, the Earth is not curvy the way it is, it's looking flat all through, then we can say the Earth is flat. But in these images, we've discovered over a long period of time that they are what? They are curvy. Now, the next evidence we have to show that the Earth is round is called lunar eclipse. Now, lunar eclipse, in lunar eclipse, the Earth actually casts a shadow on the moon. Now, one thing about the moon is this: the moon is actually a non-luminous object, meaning that the moon cannot actually produce light on its own. And it definitely means that the moon depends on the sun for its source of light. So when the Earth is in between the moon and the sun, casting its shadow on the moon, we are definitely going to have what we call lunar eclipse. Now, if we observe lunar eclipse and we observe the shadow of the Earth on the moon, you will see that the Earth's shape on the moon is actually a round shape. As you can see, these are different phases of lunar eclipse we have on the screen here. Now, if you look at it, you see that the shadow of the Earth is a round one. So with this lunar eclipse, we can also say that the Earth is round and not flat. Because if we say the Earth is flat, we are definitely going to see a flat shape, or a flat shadow being casted on the moon. But if we see a round shape on the moon, as a shadow, it definitely tells us that the Earth is what? The Earth is round and not flat. So let's look at the movement of the Earth, since we've considered the evidence to show that the Earth is what? Is round. Now, the Earth has basically two type of movement. The first one is called rotation, and the second one is called revolution. Now, rotation is when the Earth rotates on its own axis from west to east, and it brings about day and night. Now, a single rotation of the Earth takes about 24 hours. So, rotation of the Earth is like a day for it to happen. Then we'll talk about revolution. Revolution is when the Earth goes round the sun in its elliptical orbit, and it takes about 365 1/4 days. And this revolution brings about change in season, and it also causes what? Change in year. So we are going to look at the rotation of the Earth. Now, like I said previously, it's the Earth spinning on its own axis. Now, the axis of the Earth, or the Earth is actually inclined at an angle of 23 1/3 degrees to its what? To its axis. That's the angle of inclination of the Earth to its what? Axis. And it's, like I've said previously, it takes 24 hours to complete one rotation while it's inclined at that angle. And during these 24 hours, the Earth will spin 360 degrees. And in this 360 degrees of 24 hours, we are going to have 12 hours of daylight and 12 hours of darkness. So 12 hours day, 12 hours darkness. And as a result of that, in these 24 hours, every 1 hour, the Earth will spin an angle of 15 degrees. So the Earth rotates at 15 degrees in 1 hour. And if you divide it further, you discover that the Earth rotates at an angle of 1 degree in every 4 minutes. So this is that's the rotation of of the Earth. Now, what are the effects of the Earth's rotation? Now, number one is that rotation causes day and night. So when the Earth is rotating, you discover that for 12 hours of the day, the one side of the Earth we experience day, and the other side we experience night. And the other 12 hours, the reverse is going to happen for both sides of the Earth. That's why you see in a day, every side of the Earth we experience darkness and and daylight in space of 24 hours. Now, the rotation of the Earth brings about change in time zone. We have time differences from place to place. Okay, let me give an instance now. Here in Nigeria, we use the GMT+1. Now, if you go to USA, let's say New York City to be precise, you will discover that people in New York City are actually 5 hours behind us. So whilst we are in darkness, they are still They are still experiencing daylight. Let me give an instance. Let's say this is 8 p.m. in Nigeria here. Now, in New York City, the time there will be with 3 p.m. So there will be time difference, and not just time difference. They will also we are also going to experience night while they experience day. And due to the Earth's rotation on its own axis, we have what we call deflation of rain and ocean current. You see that the northern hemisphere will be deflected to the right and the south to the left. And this theory is actually called the Ferret's law of deflection, and it's actually caused by by the rotation of the Earth. And another effect that the rotation of the Earth causes is the daily rising and falling of the tides. Now, when the Earth is rotating, the Earth is actually influenced by gravitational pull from the sun and also from the moon. Now, these gravitational pulls actually cause the tides of river to rise at a certain time of the day and also to fall at a certain time of the day. And the last effect of rotation we have is that it brings about dawn and what? And twilight. Now, dawn is actually a brief period, you know, before morning. You know, that brief period of darkness we do experience for morning. And the twilight is the reverse of what? Is the reverse of it. Now, these things are actually, this effect are actually caused by the Earth rotation. When the Earth is slowly, you know, rotating away from darkness to light or from light to darkness. And these are one of the effects we have when we have what? Rotation of the Earth. So let's look at the next movement of the Earth. The second movement of the Earth is actually called revolution of the Earth. Now, the Earth is actually revolving around the sun, you know, just like other words, planets do. And the orbit of the Earth is actually an elliptical orbit, just as we have here. As you can see, this is an elliptical orbit. So you see the Earth is actually inclined at an angle of 66.5 to the orbit of the Earth. So take note, the Earth is inclined 66.5 to the orbit, and on its own axis, the inclination is what? 23.1 degrees. So these are the two different what? Angles of inclination the Earth has on its axis and on its orbit. So when we have such inclination, we are definitely going to have what? An anti-clockwise movement around the what? Around the sun. So this revolution actually, you know, takes 12 months, and it brings about what? Seasons. So you see that for the Earth to make one revolution, you know, it will take 52 weeks, that's 365 days. And the 1/4 day that is added to the 365 is actually measured in space of 4 years to be seen as a leap year. So the 1/4, when you add it for this year, you add it for the next year, you add it for the third year, add it for the fourth year, we are going to have what? Have a full day, because 1/4 is actually 6 hours. So when you have a full day, we add it to the fourth year. So the fourth year is going to have what? 366 days instead of 365 1/4. That idea of leap year was actually first you know, propounded by Eratosthenes. So these are some of the things you should know about about the Earth's revolution. So let's look at the effects of the revolution of the Earth. What are the effects? Just as we have rotation causing an effect, revolution also brings about its own effect. So the first effect is called change in season. Now, due to the movement of the Earth around the sun, we actually have four seasons, and these seasons are actually caused by what? Caused by the angle of inclination of the Earth to its orbit and the position of the Earth away from what? From the sun. We have basically 4 major seasons in the world. We have the winter, we have the summer, we have the autumn, and we have the spring. These 4 seasons are actually caused by inequality in day and inequality in the amount of sunlight being received in the northern and southern hemisphere at different points of the year, and they actually interchange, you know, from the north to the south. What I'm trying to say is that at the month of December, specifically December 22nd, you will discover that people in the southern hemisphere will experience the summer season, while people in the northern hemisphere will experience the winter season. Then when we get to June, specifically June 21st, people in the northern hemisphere will experience summer season, why people in the southern hemisphere will experience the winter season. The same applies to autumn in the northern hemisphere in the month of September. You will discover that people in the northern hemisphere, they have autumn, while people in the southern hemisphere, they have what? Spring. Then you go to the month of March. In the southern hemisphere, they have autumn, while people in the northern hemisphere are going to experience what? The spring. So these change in seasons are actually caused by what? By the Earth's what? By the Earth's revolution. The next effect of evolution is the change in the altitude of the midday sun. Now, if you observe the Earth, you discover that different hemispheres of the Earth, they actually experience different amount of sunlight, especially during one season or the other. But if we consider the equator, the sun is always overhead at the equator due to its position, when compared to the northern hemisphere and the southern hemisphere. Now, for the northern and southern hemisphere, the amount of sunlight is actually dependent on the distance of, that hemisphere from the sun, and it usually varies during what? The summer and the winter, meaning that during the summer, places in the northern hemisphere, especially for summer in the northern hemisphere, places in the northern hemisphere there will actually experience a longer amount of what? Of day, and the sunlight there will be much more visible compared to places in the south, and the reverse will as well happen during what? Summer in the south. Then another effect of revolution is that revolution causes what? The length of day and night to what? To vary, especially during what? Summer and winter. During summer, maybe summer in the northern hemisphere, for instance, you will discover that the length of day will be much more longer compared to the length of night in the northern hemisphere. And for the southern hemisphere, during that same period, they will have a longer night than the day. That is shorter day and longer night. And we actually call this equinox and what? And solstice. And revolution also has what? Has its role to play what? Play on temperature, because while the Earth is rotating, places that are further away from the sun will have a drop in temperature, while places that are closer to the sun will always experience what? An increase in the amount of temperature. So let's look at the differences between the rotation and revolution. Now, for rotation, the Earth is rotating on its own axis, while the sun is revolving on its elliptical orbit, while the Earth is revolving on its elliptical orbit around the sun. Now, rotation takes about 24 hours for the Earth to go 360 degrees on its axis, while revolution takes about 365 1/4 days for the Earth to go around its orbit. Then for rotation, the angle of inclination is 23.5 on its axis, while that of revolution has an angle of inclination of 66.5 on its elliptical orbit. Then rotation brings about day and night, revolution causes season. Rotation of the Earth is just 1 hour, and 15 degrees per meridians apart, while revolution can only cause what? Cause a change in the altitude of the midday sun. Now let's look at the two factors that brings about varying length of day and night. And these two factors are actually called equinox and solstice. Now, equinox can be, is actually coming from the word equi, which means equal. So when we talk about equinox, we are actually talking about, a time of the year where we have an equal duration of day and an equal duration of what? Night. So we can put it simply as equal day, equal night. And during the year, we have two, equinoxes. We have two. The first one is on the is during the month of March, on the 20th of March to be precise, and we call that spring equinox. Then the second equinox is in the month of September, 22nd of September to be precise, and we call it the autumnal equinox. So we have the spring equinox at during the month of March, and we have the autumn equinox during the month of what? September. And during these periods of the year, we experience what? Equal day and what? and equal night. Then when we talk about solstice, on the other hand, we are actually talking about a time of the year when we have unequal length in day and what and night. So we have either the longest day, long day, short night, or short day, long night. And in the globe, we have two solstices. Now, the first one is called the winter solstice in the month of December 22nd, and we have the summer solstice in the month of June 21st. Now, I want to use the summer solstice as an example. On the 21st of June, at the Arctic Circle, that is 66.5 degrees northwards, you discover that we are going to have basically, we are going to have a longer day and shorter night in the northern hemisphere. But at the Arctic Circle, we experience 24 hours of complete daylight. That means the sun is visible for the 24 hours period of that day. And Arctic Circle is actually regarded as the land of the midnight sun. So let's look at the diagram explanation of the equinox and solstice. Now, if you observe, these are four phases of the Earth's revolution, and the four phases signifies the four seasons, because these are the periods where we have the four seasons coming into play. So we start with the equinox, the spring equinox, which is in the month of March 20 to 21st, and in this period of the year, you will see that both the northern and southern hemisphere will actually have a considerable amount of sunlight. There will be equality in the amount of sunlight received even at the equator too. So therefore, as a result of that, we have equal number of day and night. The same applies to that of the September 22nd and 23rd, where we have the autumn in the northern hemisphere. At that period of the year, even people in the south, we experience the same amount of sunlight, like they will have equal day and equal night, same as that of the northern hemisphere. But for the solstice, which occurs in the month of June 20 to 22nd, and in the month of December 21st to 22nd, in the month of June, we'll have the southern hemisphere further away from the sun, and you will see that the northern hemisphere will be closer to the sun compared to the southern hemisphere. So people in the northern hemisphere will experience more of sunlight, and they will have longer days and shorter nights. And in the month of on the 21st of June, you will see that at the Arctic Circle, up just right here, we are going to have 24 hours sunlight all through. Now, the reverse happens in the month of December, when we have winter. Most places in the northern hemisphere can experience darkness all through, especially people in the Arctic Circle. While people in the southern hemisphere, they are going to have They are going to have longer days and shorter nights, and more of sunlight, because they will experience summer more than people in the northern hemisphere. So this is what actually happens during equinox and solstice. And as a result of this, we are going to experience different seasons, and also we are going to experience different lengths of day and night. So it's time for us to look at the exam guide application. Okay, this is the exam guide application. Now let us take some questions concerning the Earth, its sphericity, and also revolution and rotation. So we use the exam guide. Let's take questions from 2007 SSCE. So we go to let's go to question number 10 or 11. Let's look at question number 11. And question number 11 says, which of the following does not prove that the Earth is spherical in shape? Which of the following does not prove to us that the Earth is spherical in shape? Okay, A says tilting of the Earth on its axis. B, the curved horizon of the Earth. C, the eclipse of the moon. D, aerial photograph of the Earth taken by astronauts. Now, if we look at option D, we've talked about aerial photographs as one of the evidence to show that the Earth is, curved and not flat. Then we also talked about lunar eclipse, which is also the same as the eclipse of the moon. So it's also an evidence. Then if we looked at the curved horizon of the Earth, we as well discussed option B. So the answer will be what? Tilting of the Earth on its axis, because that one talks about rotation of of the Earth. So the answer is what? Is A. So we go to the next question. The next question says, during equinoxes, A, there are 6 hours of darkness and 18 hours of daylight in the northern hemisphere. B, there is complete darkness for 24 hours at the North Pole. Now C, there is continuous daylight for 24 hours at the South Pole. And D, days and nights are equal in length for all places throughout the world. Now, when we talked about equinox, I told you simply put it as what? Equal day and what? Equal night. So we have 2 equinox, the one at March and that of September. So when you consider these 4 options we have here, and you look at option D, it says days and nights are what? Are equal in length for all places throughout the world. That means the correct answer will be what? Will be option D. And then let's look at the last question we have for this topic. The last question says, the movement of the Earth round the Sun is termed the Earth's dash. A, evolution. B, revolution. C, rotation. D, orbit. And the correct answer when we say the Earth is moving around the Sun is what? Is revolution. So the answer is going to be what? Is going to be B. And I hope you got it right too. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It's a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.